Hello everyone, welcome to Chem with Reason. And today I would like to talk to you about the periodic table and why is it designed this way by Mendeleev, and basically explore its arrangement and its significance in many ways, such as chemical and physical properties. And this topic will be crucial for your GCSE studies or other qualifications of the same level, and also your studies in the future about chemistry or other scientific subjects. And so through this video, I really hope I might be able to explain things that you might not understand before, so that ultimately the goal is that you enjoy chemistry more and hopefully spark your interest. So first of all, I would like to define elements, which are basically different types of atoms with different number of protons and electrons. And within each element, they have different isotopes with different number of neutrons with the same number of atoms and electrons. And the periodic table basically lists out all the different elements that has been discovered in the universe. And it is arranged so that in each group, which are the vertical columns, have similar chemical and physical properties. And in each row, as you move along each row from left to right, you can see a clear pattern which repeats in every period, more or less. And so why it is so important is because these elements are the building blocks of all matter in our universe. And it is important to know this for different scientific research. The most famous person who configured the periodic table is Mendeleev, and he designed it with reason. The whole thing is not random, everything makes sense. So first things first, he has arranged these elements by atomic number, by ascending atomic number. So from left to right through each period, the atomic number increases. And atomic number represents the number of protons, which equals the number of electrons. And the reason for this is because protons have a charge of +1 and electrons have a charge of -1. And so for an element to exist, they must be neutral, they must be stable. And as a result, the positive charges and the minus charges must equal each other, and therefore they're always equal. If you look down into this copy of a periodic table, then you can see that a group is a vertical column. So this is group 1. Hydrogen in GCSE periodic tables, you wouldn't see hydrogen in this position. It'll be around here. And so this is group 1. And then you continue down this group 2, 3, 4, 5, etc. And for elements in each group, they have similar chemical and physical properties. The reason for this is because they have the same number of outer shell electrons. And you might know from your studies that that determines the reactions and how it behaves as an element. And so therefore they have the same chemical and physical properties. And if we look into the periods, which are the rows, so this would be a period, this would be a period, this would be a period, and as you move along a period, you get the same trends in the changes of chemical properties and physical properties. And so, by knowing this, Mendeleev was able to predict elements that haven't been discovered yet at the time. But by knowing these patterns and knowing how different properties change and how much they change, he was able to leave gaps within the periodic table. And then later, when those elements were discovered, they were able to fit perfectly into the periodic table. That's why the periodic table is this famous, especially the Mendeleev one, and has been considered a really successful and impactful scientific discovery. And so for the transition metals at this level, which is GCSE, we don't give it a group, we don't group it, we don't give it a number. The reason for this is because they all have either 1 or 2 electrons in its outer shell. And the reason for that is as you move along the periodic table and the atomic number increases, the electrons don't go to the outermost shell. Instead, it goes to an inner shell. And the reason for this is because it is more energetically favorable. Because remember, each element has a nucleus, and the nucleus is positively charged because it is made of protons and neutrons. And neutrons is neutral and protons are positively charged. So electrons join inner shells instead of outer shells because less energy is needed to join inner shells because the nucleus is positively charged, and therefore when you gain electrons, electrons would naturally go to a lower energy state. Because let's say if there are 2 options, one requires less energy, one requires more energy, of course it will go to the low energy one, and then it will just become stable. There's no reason for it to go to the higher energy level. And because the inner electron shell for transition metals have a lower energy level compared to the outermost shell, therefore the electron remains in the inner electron shell, and therefore all of the transition metals have similar, if not same, number of electrons in its outer shell. Therefore, at this level, we don't give it a number in terms of groups. So now let's move on to the different properties. As I mentioned before, each group of elements have similar properties because it has the same number of electrons in its outer shell, and that dictates the chemical reactions that it undergoes. So for instance, in this video, I'm going to cover group 1. And in group 1, within the GCSE syllabus, they ask you about the reaction with water. So why does group 1 metals react with water? Water is a molecule where electrons are not evenly distributed. Oxygen has more electrons compared to hydrogen atoms. As a result, when the 1 electron in the outer shell of group 1 metals is partially attracted to the positive ends of a water molecule, which is hydrogen atoms, because it has less electrons. Therefore, it has a relative positive charge within the water molecule. Therefore, the single electron from a group 1 metal atom will be attracted to it. And as a result, that is able to break the bond, which is here, break the bond here within the water molecule, and then the remaining converts into a hydroxide ion. And at the same time, as the single outer shell electron in the metal atom is donated to one of the hydrogen ends of the water, it becomes a positive metal ion itself. And that reacts with the hydroxide ion because opposite charges attract. One is positive, one is negative. They form a metal hydroxide. And then the hydrogen end that accepted the electron from the metal gains an electron, and when there's two of them, they're able to bind covalently. So two hydrogen atoms binding covalently to form a hydrogen molecule. So I can draw it here. So it will form this, and it will bond covalently. Hydrogen molecule. It will do this. And as you move down group 1, the reaction becomes more and more violent. And the reason for this is because the size of the atom increases. There are more protons, more electrons as you move down, because atomic number increases, which is how the periodic table is arranged. And therefore, the distance between the outermost electron and the positively charged nucleus is further away. Therefore, there's less attraction of the electron with the nucleus. Therefore, the electron is more readily lost. More readily lost meaning less energy, less activation energy for the reaction. Therefore, more readily happening. And therefore, more energy release. Therefore, more violence. The reason why it's violent is because the hydrogen gas release undergoes combustion with oxygen and air. And so, as we continue to move downwards, I want to talk a little about group 0. And this group is known as the noble gases, where, as you can see, this is a neon atom with atomic number 10, and its electron configuration is 2, 8. So you see 2 electrons in the first electron shell, and then 8 electrons in the second electron shell. And as you can see, at GCSE level, you only need to know the electron configuration for the first 20 elements. And for all of them, so the first shell can fill 2 electrons, and the second shell can accommodate 8 electrons, and the third shell can accommodate 8 as well. And a stable atom has to have a filled outer shell. And for all the possible elements that they might ask you, it'll be 8. And in this case, neon has 8 outer electron shells, and therefore it's stable. And therefore, it doesn't readily undergo any reaction because it doesn't have to. It will just stay as it is because it doesn't need to gain or lose any electron in order to remain stable. So it would have no incentive to do anything. So it is very inert, which means unreactive. So the key takeaways of this video is that the periodic table is not just a random collection of elements. Instead, it is designed carefully, most famously by Mendeleev, and it shows the trends in chemical and physical properties in terms of groups and also periods. And from this understanding of neighboring elements, at the time, not all of the elements in the periodic table was discovered during Mendeleev times, and so therefore predictions could be made very accurately. And perhaps there are more elements that are yet to be discovered. So this is a huge scientific discovery that helped with many scientific innovations in the past, such as drug discovery, which has obviously benefited many different medical patients. And so the periodic table is the cornerstone of all scientific advancements in modern days. So I hope you enjoyed this video and stay tuned for more.